So if you haven't noticed by now, most of everything that we're doing to these flames is adjusting the velocity field. And we've actually never looked at that velocity field yet, so let's do that now. Here we have the smoke object. I made another one right here, but I want to show you an issue that you're likely to run into at some point or another. If you go to the guides, visualization, and we check on velocity right there, you'll notice that by default, this velocity preview is really heavy. And what I mean by that is we're using these streamers to represent where the velocity is, and there's just a lot of them, so much that it's going to really bog down this viewport very quickly. And this is especially a problem if you have a bigger pyro simulation. So you'll want to probably change the resolution of these streamers. This represents where things are going, by the way. So you'll notice that we have this kind of shape happening here with the velocity. And depending on the color, that's like the intensity of the velocity as well. But like I said, if we want to turn down this preview resolution, all you do is you right-click on the smoke object, say Allow Editing of Contents. We're going to dive in here and do a little surgery. And then if we go over here to this vector field visualization, which is right above the velocity field right here, we have this button here that says Override Divisions. And let's right-click that, say Delete Channels. So whatever expression was there, we're going to get rid of that. Check that on. Let's also right-click this Divisions, delete the channels there, and we can specify a manual number for ourselves. So let's say maybe 50. 50, 50, 50 across the board. And now this is going to be a lot faster to load in the viewport, and this is a much more reasonable amount of streamers to be working with. So anyway, I just want to show you that. By default, it's really not set up ideally, in my opinion, because it really slows down the viewport, but I just want to show you that. Okay, so now moving on to this velocity field. What can we do to improve this? Well, I want to add a bit of turbulence, and turbulence is going to represent just an ambient sort of wind or an ambient breeze that happens within the room. Whenever we simulate this stuff, it's always going to start off in a bit of a vacuum environment. That means that there is no air movement unless we add it in. And I think it's going to look a lot more realistic if we just add in something subtle to move around these velocity vectors just a little bit as the simulation goes on. So let's create a gas turbulence node. And I want to talk about something important here as well. If we go to these inputs, we have this thing called advection. And you might think, okay, well, advection, that says, well, advection, the word, says that's how stuff moves around. So that must mean that's the turbulence. But that's not correct. And what this input is for is if, let's say, you want to have particles flying along the velocity field of the simulation, and you want to apply that data within DOPS. This does not have to do with where you plug in your microsolvers. So I just want to warn you about that because the terminology makes it sound like you could put a turbulence there because it says advection. So what you want instead is the forces right here, and you want to merge that in. Another reason why that's a bit confusing is because forces traditionally in Houdini have to deal with things down here that happen before the output. So if you had, let's say, a gravity force, it's not the forces, you know, like you're used to. This should really say, plug your microsolvers in right here. So anyway, I just want to let you know about that because you're likely to mess that up if you're not careful. Okay, so anyway, we have our turbulence. Let's visualize the turbulence right here and say a scale of something really small, like let's say 0.2, or we'll say 0.02 actually. For the swirl size, I like taking this up to a high value. So let's say a value of 5. And then down here at this turbulence, I'll turn this up to also a value of 5. And what you'll notice right away is that we don't see anything happening. Nothing's actually changed. And why is that? Well, with this gas turbulence, this is originally made for the traditional pyro solver. And so by default, it's really not going to do anything with the sparse pyro solver just because of the way that these settings are set up. Here is what I will do if I want a turbulence happening everywhere in this simulation. So the reason why it's not showing up, let me just tell you about that first. The reason why we don't see it is because this influence threshold and this density are basically telling the gas turbulence not to do anything. Because we actually aren't sourcing in smoke right now, we're looking for density and it doesn't really exist within our simulation. So because of that, that's why the gas turbulence isn't working. So let's do this. Let's take away density. So we'll just go like that. And we'll take our influence threshold to 0. And by doing that, what you'll probably notice is that there still is nothing showing up. So let me just go a few frames here. Yeah, so again, nothing's happening. So what's going on? Well, we need to also take the stencil field. This is used to basically tell the gas turbulence where it's allowed to happen, where it's not. Really the confusing thing about this gas turbulence microsolver is that there's 3 things that tell it where it can go and where it can't go. This stencil field is trying to say, hey, you can't, go here if this field has a value of 0.5 or greater, right? Just get rid of that. We don't want to deal with that. We have this density field, which is also used to mask where things are allowed to happen in combination with this influence threshold. So let's just say this. Active is now going to be the density field. And when we have an influence threshold of 0, what we're saying is that if the active field has a value of 0 or greater, then this turbulence is allowed to happen. And as you can see now, we actually have turbulence. So I know that's confusing. Like I said, this gas turbulence has 3 ways of saying where it's allowed to go and where it's not allowed to go. The stencil field is one, just get rid of that. The density field is another way of telling it where to go in combination with the influence threshold. And then in addition, you could also have this control field, which tells it where it should go. So it's a little bit messy in the way that it's set up. But just know that's what's going on. Also, this density field right here, we said active, and I haven't told you what active is talking about. Active is a field which tells the pyro solver, or the pyro solver is saying, these are areas, these are voxels which I'm allowed to think about. That's what active is specifying. And so when our density field is active, we're basically saying, hey, apply turbulence everywhere that the pyro solver is allowed to think about. In the next video, let's continue on by adjusting these turbulence settings.